Today we are discussing the next topic of the electrochemistry, that is electrochemical series. Electrochemical series is a series of electrodes or half cells arranged in the increasing order of their standard reduction potential, and here we used as the hydrogen electrode as the standard. So this is the electrochemical series. We can see the lot of elements which are arranged in the increasing order of their reduction. So first of all, we have to listen one thing, that every element are written in terms of reduction. See here, the first element is the lithium. So lithium always undergo oxidation. But even then, if you are arranging the element in electrochemical series, always write in reduction terms. So Li plus 1 electron gives Li. And here we can see that the reduction potential of the lithium is minus 3.05. So it shows that lithium always undergo the oxidation. It has a little tendency to undergo the reduction. So from the electrochemical series value, that means potential value, we know whether this compound undergo oxidation in the chemical reaction or reduction in chemical reaction. If the value of the electrochemical series is a positive, if the elements are arranged in the increasing order of the reduction potential, if the element shows the positive potential, then we can conclude that that element undergo the reduction in a chemical reaction. Now we are moving into the some of the application of electrochemical series. We have four application. So electrochemical series and application of the electrochemical series is very important. So first application is electrochemical series helps to predict the relative ease of the oxidation of the various element or relative ease of the reduction of the metallic, cation or non-metallic elements. So, as we discussed earlier, we can easily predict the character of the element by using electrochemical series. See, for example, in the lithium, the electrochemical series, the reduction potential is minus 3.05. From that, we can conclude that lithium undergo the oxidation in chemical reaction. Whereas for the fluorine, the last element fluorine, has a reduction potential of the plus 2.87. From that we can understand that fluorine always accept electron and undergo the reduction. So similarly we can determine character of the element in a chemical reaction before the actual reaction. Okay. So next application, the electrochemical series tell us about the constitution of any cell setup by combining the two standard electrode and make it possible to calculate the standard EMF of any such cell. For example, we have already discussed how to measure the potential of a electrode by using hydrogen electrode. So for a cell, we have two half cells and we can easily measure the potential of a cell by using voltmeter. So this is the equation for the potential of a cell. E cell is equal to E cathode minus E anode. So the representation of a of a cell which consisting of two half cells, one is zinc and other is the hydrogen. So we can write this cell as like this: Zn bar Zn2 plus double slash H plus slash H2. So how we will determine the potential of this or the cell potential of this cell? By using this equation, E cell is equal to E cathode minus E anode. And here the hydrogen is written in the right hand side of the cell representation. That means the hydrogen is act as a cathode. So we know that the potential of the hydrogen is 0. So in this equation we have to substitute 0 for the E cathode and minus E anode. Here the anode is the zinc We know that the potential of the sink is minus 0.76 volt. So substitute in the equation 0 minus of minus 0.76. So we will get the potential as 0.76 volt. Okay. Okay. Now, thus we can calculate the potential of any cell. Now we are moving into the another cell, galvanic cell. We have already studied the zinc as act as a anode in the galvanic cell, and copper is act as a cathode in the galvanic cell. So the potential of the zinc, I already told you that minus 0.76, and potential of the copper is 0.34 volt. So substitute in the equation E cell is equal to E cathode minus E anode. So here the cathode is the copper. So instead of E cathode we have to substitute 0.34 minus E anode is the zinc. So minus of minus, it is plus. So 0.34 plus 0.76, the value is 1.1 voltage. So this is the potential of a galvanic cell. So similarly, we can predict the potential of half cell, or we can predict the potential of a cell. Now the third application. The electrochemical series help to predict the direction of the displacement reaction. So displacement means a metal with lower reduction potential will displace a metal with higher reduction potential from its salt solution. See here I have quoted two rings, and first one is a silver ring. We can coat the gold over this silver ring. So we'll get the gold ring. Okay. So how it will possible? So this can be easily predicted from electrochemical series. In the electrochemical series, see the position of the gold, that is in the bottom level, and the potential is 1.50 plus 1.50. And for the silver, it is little bit higher than that of the gold. So the value is the 0.80. Okay, so we can easily deposit the lower element over the other element. So as the reduction potential increases, we can easily displace that salt or that ion into the solution, and we can deposit that element over the other. So we can easily deposit the gold ions over a silver ornament. So that's why it is a very important application, gold plating over a silver ornaments. The last application is electrochemical series help us to predict whether a metal will displace hydrogen from the dilute acid or not. So this is also very important application. See here, this is a magnesium ribbon is placed in a test tube, and the some of the hydrochloric acid is used in the test tube. So we can see the small bubbles in the test tube here, and that is a gas, hydrogen gas is evolving from the test tube, and that gas is collected by using a glass tube, and which is passed through a soap solution. So we can see that a gas is bubbling from the soap solution, and if you use any candle, it is easily burning. So this is a very simple evidence for the generation of the hydrogen. So you know that the hydrogen is a burning gas, and we can generate the hydrogen easily in the laboratory by using any metal. For example, calcium, magnesium, sodium. We can easily generate the zinc hydrogen element easily in the laboratory purpose. So from the electrochemical series, we can predict that whether the element can generate hydrogen or not. So every element which is in the top of this hydrogen, I have shown the hydrogen is in the red color. So every element which is above this hydrogen electrode can generate hydrogen gas, but every element below this hydrogen electrode cannot generate the hydrogen. So that is the principle. Hope you understand the concept. Thank you.